In this video we'll be looking at a couple of uses of diodes. The first use, and probably the main use that diodes is put to, is for rectification or changing AC to DC. If we put one diode in a circuit with a load resistor, and so we have current can only flow in this one direction, we put AC into the circuit. Every time the AC goes into the positive half cycle, so that we're positive on this part of the diode, negative on this part of the diode, we get an output. So current will flow, and then when the AC changes around in the other direction, we get no current flow, and so forth and so on. This, however, is the big disadvantage, is that we're only getting output for every half cycle of AC. So we call this half wave rectification, and it is seldom, if ever, used because of all the limits that are obviously on it there and the waste of power coming in. More common use of diodes as rectifiers would be in circuits where we have at least two diodes. In this particular case, when the positive half cycle of our AC was positive, so that's at the top of our transformer here, negative at the bottom, and also negative would be relative to the top, negative in the halfway around of our secondary side. Current will flow through this diode, through our load resistor, and back to the center of our transformer and around in the loop this way. On the negative half cycle of our AC, the bottom of our transformer here becomes positive with respect to the center, so current now flows in this direction through this diode, up through there, and in the same direction down through our load resistor and back through our circuit this way. This is known as center tapped full wave rectification. The disadvantage is that it only uses half the transformer secondary for each half cycle. It used to be a very common method of rectifying AC when diodes were initially invented, or we had thermonic valve diodes, which were relatively expensive and transformers were relatively cheap. So we can see our output would look like this. We have our AC input to our transformer, transformed to a lower voltage AC onto our secondary, and then our output is what we call pulsating DC, so both half cycles are going in the same direction. However, once again, this type of setup with the center tap transformer is seldom used these days because our rectifier diodes are so cheap. A more common method, or the most common method now of rectifying AC, uses four diodes in a configuration like this, also sometimes seen as these other two circuits down below here, and this is known as a bridge rectifier, full wave bridge rectifier. So in the positive half cycle, when our input is positive on this side of our transformer, negative here, current will flow this through to our diodes, wants to flow this way through our load resistor and back through this diode to our secondary of our transformer. In the second half cycle, when the current is, or the voltage is negative, going negative, current now will flow this way and through this diode. Can't go back through that one, so it'll flow through the circuit in the same direction as the other half cycle and back through this diode, so we have a constant flow of current in this direction for the second half cycle. So in each half cycle, our output uses two of the four diodes. Once again, this is called full wave rectification. And our output, as you can see, we now have all of the AC coming in, gets rectified into DC, or pulsating DC as we call it. Another use for diodes is what is known as a flyback diode or a freewheeling diode. This is used as a protection circuit. For example, when we have a device like a motor or some other form of inductive load like a solenoid or a relay, which is a coil of wire, what happens when we turn our motor off or our solenoid off? We have a large magnetic field around the coil of wire, and that energy in that magnetic field has to go somewhere, and it comes back into the circuit in the opposite direction that that the current caused it to be set up. So in the initial case, we have current flowing from our power supply through our motor in this circuit here, and because conventional current flowing can't flow against the diode, so we get no current flow in that direction through our diode. Just the current will go there. It doesn't want to come back through here to positive. It wants to go from positive to negative, so current flows in this direction. When we turn our circuit off though, the energy that's around the motor in the form of a magnetic field collapses back into the motor and would cause a high voltage spike. So and it's in the opposite direction to the voltage that set it up. So in that case, this part of our circuit becomes positive and this part becomes negative, and now current can flow through our diode this way and short that high voltage out, and the current will quickly dissipate without damaging anything else in the circuit. This is particularly important when we are looking at other semiconductor devices like transistors, etc., and we want to protect them from these high voltage spikes, especially inductive loads like motors, solenoids, which they often control. So if we have a semiconductor device like a transistor, and we'll be looking at them later on in this course, when the transistor turns off and turns the power to our inductive load off, the reverse voltage gets shorted out by this protection diode, and any current just circulates around here till it dissipates. Right. So both of these circuits are either called flyback diodes or freewheeling diodes. Those are the two names that are given to them. And that's the two uses which diodes are commonly put to: rectification and freewheeling or flyback diodes as protection circuits.